Chapter 3, Number 18. A treasure map directs you to start at a palm tree and walk due north for 15 meters. You are then to turn 90 degrees and walk 22 meters, then turn 90 degrees again and walk 5 meters. Give the distance from the palm tree and the direction relative to north for each of the four possible locations of the treasure. Why are there possible locations? Why are there four of them? Because we can either go left or right at the first turn, and then for each of those we can either go left or right at the last turn. So we can actually end up with four possible things we do. So let's say we do the first case, we always go right, sort of maze solving algorithm 1. So we go north 15, and then we turn right and go 22, and then we turn right again and go 5. So 15, 22, 5, and we end up at whatever that spot is, and that's the angle they want. All right, we want the length and distance of that angle, which I'm going to call A and theta sub A. And that's not so bad. We can see that the total thing, AX, is going to be 0 for the first leg, plus 22 for the second leg, plus 0 for the third leg. So that's 22. And A sub Y is 15 north, plus nothing for the second leg, plus negative 5 for the third leg, or 10. A is just the square root of AX squared plus AY squared. So we end up with, we get 22 meters quantity squared plus 10 meters quantity squared, and then square root of the whole thing, and that comes out to be 24.2 meters, where we have 3 sig figs in everything, but we have only one decimal place in 2 of them, so we only get one decimal place out. So 24.2. And we could even get the angle, because we can say that we have 10 that way and 22 that way, and I want that angle. So the tangent of theta sub A is going to be the opposite over the adjacent, which is going to be 22 over 10. This implies that theta A is the inverse tangent of 22 tenths, which calculator gives us as 65.6 degrees. So that's option A. Option B is that we travel 15 meters north, and then we turn right and go 22, but at the end we turn left and go another 5. And I'm going to call this vector, oops, well, not that. I'm going to call this vector B, and this angle theta B. And here we'll have basically a BY and a BX. And we can see that BX is 0 for the first leg, plus 22 for the second leg, plus 0 for the third leg, or still just 22. And BY is going to be 15 for the first leg, and then nothing for the second leg, but then 5 more north for the third leg, and therefore a total of 20. So we have a triangle whose sides are 20 and 22, and we want to get the length and the angle of that. So we say, okay, well, B is still going to be BX squared plus BY squared square rooted, which is 22 meters quantity square plus 20 meters quantity squared square rooted, which is 29.7 meters. And then along the same lines, we can find that tangent of theta B is opposite over adjacent. Notice for us the opposite was BX and the adjacent was BY, which is 22 over 20, implying that theta b is the inverse tangent of 22 over 20, which is 47.7 degrees. You'll notice in both these cases our tangent ended up being the thing in x over the thing in y, even though in class we had said that the tangent was thing in y over thing in x. And the key bit, the difference here, is that we are measuring our angle relative to the vertical. And that swaps the role of x and y. That'll come back to us in chapter 5 a bit as well. Okay, option C is that we walk north for 15. And instead of turning right, we turn left and go 22. And then we turn right and go 5. And we're interested in this, which we'll call C and theta C. But I am remarkably lazy and will not actually do this because we can see this is the mirror image of case B, where we had this, and that was case B. And so the length will clearly be the same. So C is also 29.7 meters. And theta C is also 47.7 degrees. And my justification for that will be by the symmetry of the problem, which sounds a little bit like a thing from He-Man, like by the power of Greystone, but it's actually way more powerful in physics. Whenever we can say that there's some sort of simple symmetry, it allows us to really short circuit and not have to do math because we've already done the math. And so part C, I've actually talked way more than part C really justifies. It is the same as part B, except reflected about the y-axis. And now option D is kind of anticlimactic. It's the same idea. We go 15 north, we go 22 to the side, and we go 5 down. Give myself a little more room. And we get a thing that is the mirror image of our original 15 north, 22 over, 5 down. And therefore, right, this was vector A, and vector D has to basically be the same magnitude but pointing to the west by the same angle that A pointed to the east, which means we can just jump to, by symmetry, saying that D is 24.2 meters, and theta sub D, which would be this, is 65.6 degrees. And that's it. Those are our 4 possibilities, and there are answers for all of them.